Okay, so well, and each photon or quanta, these particles of light that come out, they come out in fixed number, like it can be 1h mu, 2h mu. Okay, they are quantized. I hope you guys know what is the meaning of quantized, right? Quantized means fixed number, like it cannot be a fraction like 4.25 or 5.5 or anything. It should be integral multiple of h mu, means the value of each quanta is quantized, means they come out in fixed numbers like 1 quanta, 2 quanta, 3 quanta, like 1h mu, 2h mu, 3h mu, 4h mu, and so on, which is called quantized. Quantized means perfect integral, whole number, perfect number, like 1, 2, 3, 4, 5, 6. And these small bundles of energy come out in a fixed number, 1h mu, 2h mu, 3h mu, 4h mu, and so on. Okay, there's no place for fractions here, and quantized means fixed integral multiple of h mu here. Quantized means fixed whole number, like 1, 2, 3, 4. It has got nothing to do with fractions or decimals. All right, pause it. Postulates of Bohr's atomic model. So according to Bohr's atomic model, the first postulate is electrons move around the nucleus in certain specifically permitted circular orbits known as energy levels or energy states. Okay, so these are those energy levels. Like the one which is nearest to the nucleus is the K shell. You have done it in class 10. These are also known as energy level. Then the next energy level, second energy level, is the L shell. Then the next energy level, third energy level, is the M shell. And according to Bohr's postulate, it means that electrons would be moving around the nucleus in this fixed, these are all fixed orbits, right, energy levels, and the electrons are moving around these orbits or energy levels, whatever you say, they are fixed in number. Okay, now let's move on to the second one. So while moving in a particular energy level or energy state, an electron neither loses nor gains energy. So if there is any electron, like suppose this electron is moving, like let's talk about the electron in this M shell. So it continues to be moving, all right. So while the electrons are moving in a particular energy level, they will neither lose energy nor are they going to gain any energy. Okay, there will be no loss or gain of energy. This is Bohr's second postulate. Okay, so this is the reason the energy of an electron in a particular energy state always remains fixed. Obviously, this is the reason why the energy of a particular shell energy level will remain fixed, because the electron in that particular shell is neither going to lose energy nor going to gain energy. Now coming to the third one, only those energy levels or energy states are permitted in which the angular momentum of an electron is an integral multiple of h by 2 pi. H by 2 pi, where h is the Planck's constant, right? So what did he mean by this? He meant that there are, if you guys think that there are only KL, MN, OP shell, it's wrong. There are n number of shells, okay? There are many shells, like many shells, but only those shells are accepted, okay, which are perfect integral multiple of this angular momentum. Pause karo ek second. So the third postulate states that the angular momentum of an electron should be equal to the integral multiple of h by 2 pi. Only those energy levels are going to be chosen, rather I should say. There are many energy levels, but only those energy levels are accepted or chosen in which the angular momentum of an electron, what is momentum? Mass into velocity. And angular momentum, there is angle, right? So there will be angular momentum, right? So radius has its part to play, and that is why angular momentum is mvr. Only momentum would have been mass into velocity, but angular momentum is mvr, mass into velocity into radius of that atom, right? So only those energy levels are going to be accepted where the angular momentum of an electron should be the integral multiple of h by 2 pi. Means it can be 1h by 2 pi, it can be 2h by 2 pi, 3h by 2 pi, 4h by 2 pi, okay, and so on. I hope it's clear to you, okay. So an electron can have the values h by 2 pi to 2h by 2 pi, 3h by 2 pi, 4h by 2 pi, and so on. Now coming to the fourth postulate. According to the fourth postulate, what happens whenever an electron accepts or absorbs, gets energy from the external source? Obviously, it's carrying a lot of energy. Now it doesn't want to remain in the present existing shell it is in the present energy level, because it has gained energy. So it will jump to the next energy level. So for example, if any electron is in the K shell, and if it gains energy from the external source, then it's going to jump from K to L. Why? Because it has gained energy. Alright. Let me give you an example. Suppose, for example, when we get up, we have our breakfast, we have our glucose and everything, then you are totally energized. So in that case, you can play sports, you can go to the gym, you can do anything because you are full of energy. So in the same way, these electrons also, after gaining energy from the external source, will jump from their lower energy level to their higher energy level. K is the lower energy level, L is higher than K, M is higher than L, N is higher than M, and so on. Okay, so let's say if an electron is in the N shell, by gaining energy from any external source, it's going to jump to N shell. In the same way, just as, let's say, after doing a heavy workout, we are totally exhausted because we have lost a lot of energy, right? And we are totally exhausted. So similarly, when any electron loses energy, so it will jump from its higher energy level to its lower energy level. So when an electron moves from higher energy level to lower energy level, it will emit energy, it will give out energy. And when it moves from lower energy level to higher energy level, it will absorb energy. Okay, pause. So obviously when an electron will jump from its lower energy level to higher energy level, as I told you, it is going to absorb energy. So what will be the value of that energy? The value of that energy is going to be the energy of the higher shell, higher energy level, minus energy of its lower energy level. Let's say an electron is jumping from K to L. So what is the amount of energy that electron is going to absorb? So it will be energy of the L shell minus energy of the K shell. Isn't it? Energy of this shell, let's say this is E2, let's say this is E1. So E1. So here is the electron. It's going to jump from lower to higher energy level. Okay? So hence, what is the amount of energy that this electron is going to absorb? The amount of energy that the electron is going to absorb while jumping from its lower energy level to its higher energy level, numerically its value is going to be equal to E2 minus E1. Means value of the higher energy level minus value of the lower energy level. Is that clear? And it's going to be the same while jumping from the higher to lower energy level. It's going to be the same. You just subtract it will be the difference of those two energy levels. The amount of energy emitted or absorbed by an electron is going to be equal to the difference of those two energy level from where the transition is taking place. Pause.